Okay, now we will talk about how to compute the velocity and the acceleration in angular and linearly. Okay, we know how to calculate to find the velocity linearly, linear velocity, which is delta x over delta t. The acceleration is equal to delta v over delta t. Okay, but we need also to know the angular velocity and the angular acceleration. Assume that we have this circle with radius 2 meters. We have 3 sections, the yellow one, the orange one, the green one. For each section we have period of time which is 2 seconds. And the motion circularly, we have this S1 from theta 0 to theta 1. And we have S2 from theta 2 to theta 3, and we have S3 from theta 3 to theta 4. All have the same time, 2 seconds. Now, the angles we have theta 0 is 0 degree, which is equal to 0 in radians. We have theta 1 is 30 degrees, which is equal to 0.52 in radians. We know how to convert them. We have theta 2 75 degrees, which is equal to 1.31 radians. Theta 3 is 105 degrees, which is equal to 1.83 radians. And finally, theta 4 is equal to 145 degrees, which is equal to 2.53 radians. Now, we know how to find the length of each section, S1, S2, S3. S is equal to the radius, which is constant, 2 meters, multiplied by the angle that cover this section. So we have the first section is equal to the radius multiplied by this angle, or the difference in angles, which is theta 1 minus theta 0. Theta 1 minus theta 0, it is this angle. Okay, theta 1 minus theta 0, as we said here, theta 0 is 0, theta 1 is 0.52 in radians. The difference between them is 0.52. So for r is equal to 2 meters, S1 is equal to 0.52 multiplied by 2, which is the radius, which is equal to 1.04 meters. This is the first length, S1. What about the second length, this one? The radius is the same, 2. And the difference between theta 3 and theta 2, this is theta 3 and this is theta 2. It is the same, it is 30 degrees, because 105 minus 75, which is equal to 30 degrees. In radians, it will be 0.52 in radians. Okay, so if we need to find the velocity, the tangential velocity here, we will find it now, but we find that length S2 is equal the same as the length S1, 0.52 multiplied by 2, which is equal to 1.04 meters, because we have the same angle, 30 degrees, 30 degrees. But this angle is not 30 degrees. It is the difference between theta 4 and theta 3. Theta 4, 145 minus 105, which is equal to 40 degrees. But 40 degrees in radians, it will be 0.7 radians. To find the length S3, we need to multiply the angle 0.7 by the radius, which is 2. It will be 1.4 meters per second. the velocity, the tangential velocity here is 1.4, but the tangential velocity, the length, not the velocity, the length S3 is 1.4. The length here is 1.04, and the length here is 1.04 meters. Okay, for the same time, which is 2 seconds, we have more distance here. That means the velocity here is more than these two sections. Let us now compute the velocity for the first section, which is v1, which is equal to the length, which is 1.04 divided over a 2. It will be 0.52 meters per second. So the velocity here, v, is equal to 0.52. Also, the next section have the same velocity because we have the same length. So the velocity here is also 0.52. It is the same like this one because we have the same radius, the same angle. But here we have different angle. We have the same radius but different angle. Look, because the length is more, then the velocity will be 1.4 over 2, which will be 0.7 meters per second. So the velocity here 0.7. Okay, we have a moving body from here through S1, and this moving body is move also through S2 with the same velocity. If the velocity is the same, then the acceleration will be 0 because there is no change in velocity. But from V2 to V3 we have change in velocity. Let us now compute the tangential acceleration, which is V2 minus V1. V2 is 0.52 minus V1, which is the same, which is equal to 0 meter per square second. This is the acceleration between the yellow section and the orange section. There is no acceleration. But if we need to find the acceleration between the orange and the green one, we have change in velocity. Then we have the acceleration between 2 and 3, which is v final minus v initial over delta t. V final is 0.7 minus 0.52, which is equal over 2. Then the acceleration will be equal to 0.9 meters per second. We have acceleration between these two sections. The acceleration for the tangential direction. We are not talking about the angles now. We are talking about the linear motion on the circle edge. Okay, now we need to talk about the angular motion. For the thetas, we have the motion from theta 0 to theta 1. Delta theta in this section, yellow section, is 30 degrees, as we see, from 0 to 30, which is equal to 0.52 radians. During time, 2 seconds. Also, look at these two quantities. Also, between the point 2 and 3, we have change in the position, angular position, 0.52 radians. It is 30 degrees, but we need it in radians during the same time. The third section, which is the green one, the change in position, angular position, is 0.7 radians during the same time. So now we have 3 positions, 3 changes in positions between the section 1, section 2, section 3. We need to calculate omega, which is the change in position, delta theta, angular position, divided over the time period. The change in position is 0.52 over 2. It will be equal to 0.26 radians per second. We are talking in radians. The second section it is the same velocity because we have the same change in angular position. So the angular velocity will be omega 2 is equal to 0.26 radian per second. It is the same. What about the third section? We have more velocity. So delta theta between 3 and 4 over the time period, it will be 0.35 radians per second. We have change in velocity, in angular velocity in the third section. So we have acceleration in this section, between this section and the section before. Let us now compute the acceleration, the angular acceleration, not the linear acceleration as we did in this sheet. As we see before, the acceleration will be the change in velocity, but here angular acceleration is equal to the change in angular velocity, which is omega 2 minus omega 1. Omega 2 is equal to omega 1. The change between them is 0. Then the acceleration between the first two sections, the orange and the yellow one, the angular acceleration is 0 radian per second squared. Now what about the change in velocity, angular velocity between these two sections? We have acceleration. Now we will see how. We have omega 3 is equal to 0.35. We find it. Omega 2 is equal to 0.26 radian per second. And the time is the same period, 2 seconds. Now, the angular acceleration between 3 and 2 is equal to the change of angular velocity between 2 and 3 over delta t. The change in angular velocity is 0.35 minus 0.26, which is equal to 0.09 over 2, which is the delta time, the change in time. Now the acceleration is equal to 0.045 radian per square second. We have positive acceleration because omega 3 is more than omega 2. Then we have raising in that velocity. That means the acceleration, the angular acceleration is positive. But if omega 3 is less than, then the acceleration will be negative. Look, as we compute the linear length, we have also angular length or angular position. The linear position is S. The angular position is theta. Now we have the velocity, linear velocity, tangential velocity is V as we know from before. But the angular velocity is omega, radians per second, not meters per second. Also we have acceleration, linear or tangential acceleration, meters per squared second. We have also angular acceleration, radians per squared second. When we have change in velocity, then we have a value, a magnitude for our acceleration, as we have here. If we have change in angular velocity, then we have a magnitude for the acceleration, angular acceleration. But when we have acceleration 0 in angular as an angular acceleration, as the linear acceleration may we have 0 acceleration. You need to resolve this one. You will find like this example in the lab working, and that's all for this section. Thank you.